All right, so before we work it out, I'm going to write at least one version of each of the two cosine formulas that you need, and then the area ones so that we can kind of review the formulas that you need to know for tomorrow. So if I want to find the side of a triangle using law of cosines, like a squared would equal the sum of the other two sides squared, so b squared plus c squared minus 2 times the product of those two, so 2bc, times the cosine of the angle that is opposite the one we're trying to find, matching letter, which would be A. And then the pattern follows, from there on out. And then if I want to find the angle, so let's say I'm trying to find angle A, cosine of angle A, I need to know all 3 side lengths, and it would be the other 2 side lengths again added together, so b squared plus c squared, minus the side length that matches the letter you're looking for, over 2 times b times c, the 2 angles, or the 2 letters that don't match what you're looking for. And then the last thing that we learned about is the area formula for Herons. We learned that S is A plus B plus C divided by 2, and then we learned that area is equal to the square root of S times S minus A times S minus B times S minus C. All right, so if I look at number 1, what types of information are you given? All 3 sides, which means you have to use the cosines. You're trying to find an angle, and specifically which angle? I'm looking for C because it's the largest one. So I go to cosine of C would equal A squared plus B squared, so 7 squared, plus 10 squared minus C squared, which is 15, over 2 times 7 times 10. And then again, make sure you're practicing this in the calculator because the way in which you type it is important. I would do cosine -1, open my parentheses, so there's a double parentheses at the top now. 7 squared plus 10 squared minus 15 squared, close the parentheses, divided by, open the parentheses, 2 times 7 times 10. Maddie, did I do something wrong? Oh, okay.
Is it like an actual rule to start with the longest side?
If you're going to switch to law of sines, you have to use the largest one first. If you're going cosine all the way through, it doesn't matter. But if you're going to switch to law of sines, you are creating an ambiguous case that doesn't exist. So you have to use law of cosines and start with the biggest one. You have to start with the biggest one. So 8. So angle C, 122.88 degrees. Again, make sure you're labeling them carefully. Make sure that you can tell the difference between your angles and your sides. Give me the degrees on the angles, and make sure you put the little symbol in front of it, because a C looks like a C, whether it's capital or lowercase, so you don't want to mix them up.
If you're continuing with cosine, does it matter which side you start?
Nope.
And if you're continuing with sine, do you go down the next?
Doesn't matter.
One? Okay.
Because you eliminated the possibility of that second one by doing the biggest one first, you're okay. Yeah. So from here, you can choose to either switch to law of sines or keep with law of cosines. How many of you switched, out of curiosity? Okay. How many of you kept? Okay. So about the same. So let's say I go to law of sines, so we can review that kind of quick. Let's say I'm going to find A next. So I have the complete ratio in the C, so 15 over the sine of 122.88 equals A over the sine of A. Oh, sorry, I know A. Seven over the sine of A, and then cross multiply and divide. So 7 times the sine of 122.88 divided by 15. I get 0.39. Second sign that answer. And I get angle A is 23.07. What would have been the benefit to sticking with law of cosines? What was it? It's more exact because, what did I just have to use? A rounded angle for sine. Yes? I think when we worked it out, the first class for this one, it didn't matter. I got the same answer either way, but you won't know that, okay? So more accurate to stick with all 3 sides because you're not using anything that's rounded, okay? But as long as you're showing your work and as long as you're within the nearest tenth, you're fine. So then the third angle, I would just do 180 minus 122.88 minus 23.07. So angle B, 34.085. You're going to get like one line off to the right. You're going to just give me a list. So you want to make sure that they're labeled and they're nice and clear. Okay. Questions on 1. Yep.
Do we get points off if we don't put a little degree symbol?
If you don't, and if you leave off the degree symbol and the angle thing, and I can't tell that that's what it's that's a problem. If you give me angle C and you forget the degrees, as long as I can figure out what it is, you're okay. All right, so then 2, what I have seen though, I'll just give you this warning, is people actually not do it when they write out their answers and then they write the wrong ones in the wrong spots or use a side when it should be an angle. So you just want to be careful, especially with the C's, right? Big C looks a lot like little c. All right, so number 2 is now our side angle side case. So the first thing I have to find is what? Side A. So A squared would equal B squared plus C squared minus 2BC cosine A. So B squared is 4, C squared is 9, 2 times 4 times 9 times the cosine of 135. And I'm going to make sure I square root this at the end. So the square root of 4 squared plus 9 squared minus 2 times 9 times 4 times the cosine of 135. And I get 12.16. Good so far? Okay, now I've got my one side length. I can find my other angle. So if let's say I go to angle B, so I would do, and again, you can switch law of sines or law of cosines. I'm just going to do cosine so we get the practice. So cosine of B would be A squared plus C squared minus B squared over 2AC. So 12.16 squared plus 9 squared minus 4 squared over 12.16 times 9. This time you had to use that A either way, the rounded one either way, so there's not really a benefit to doing one over the other. So I get 13.46. Carlos.
Once again, that ratio for the A, can you use that to find the angle and the angle?
Yep. So then the last one, angle C, 180 minus 135 minus 13.46, 31.54. Monica.
When I did it with the law of sines, I got 13.45.
Yeah, you're fine. I like just that's what's gonna happen, right? Because we're rounding. It might be a little bit off. As long as you're within the nearest tenth, so as long as your 10th is right, you should be okay. And again, your work would be what backs you on it. All right, and then the last one in here is the area. So the area of the triangle with the given side lengths. I know I have to first find S, which is 2.5 plus 10.2 plus 9 over 2. And what are we not going to do with S? Round it. Don't round it. Okay. This time it's not that many. It's like 10.85. But if it was a third digit, I would keep it. So I get the square root of 10.85 times 10.85 minus 2.5 times 10.85 minus 10.2 times 10.85 minus 9. And you get 10.4376. So 10.44 units squared.
Can we do that when it's side side side?
Yeah, so there's going to be two questions for area, right? One would be from your law of sine sections, which is where you get two sides and the included angle. And that's your 1/2 AB sine of C, that formula. And then the other where you get all three side lengths, and you would use this one. Should you have, like, not outside of your quiz, maybe like, should you have a triangle in which you know all the sides and all the angles of it, you could choose. And both of them should give you the same formula. You could either pick two sides in the included angle and use that first one, or you could use all three sides and use the Herons formula, and you'll get the same answer. But it'll be specific. It's either going to give you one piece of information or the other. Everybody good on warm up? Yes? Okay, so homework. All right, so we're good on like side C, right? You found side C. C squared 6.25 squared plus 2.15 squared minus 2 times 6.25. This gives you, okay, so if you move to A next, like A, B, C, this is 4.21 A, B. So I have to use C if you're using signs, right? And if you use A or B, you're actually introducing your ambiguous case, right? And that's why it's possible to get two answers. And it's not that it's two answers that are right, it's two answers and one of them is wrong. So my advice is stick to law of cosines. Law of cosines will rule out that ambiguous case. So I would just go on to A or B using the sides. So whether you do law of sines or you do law of, I'm sorry, whether you do A or B, it shouldn't matter, but if you do cosine of A equals B squared plus C squared minus A squared. And then I want to go back to agreement and second notation. So just be careful, because depending on what information you can grab, and remember there's like not any way to determine that. Like I can't look at that and figure that this is that kind of problem until I grab that information and I realize that it's the angle side angle, or side angle. So my advice would be to stick to the law of cosines there.
Wait, so you can't use sine?
It depends on the information that you're given and what you're finding, right? So like if I used on this one, they're all going to be side angle. So once you find that first one, it doesn't work.
Okay.
Because you're not starting with the biggest angle. Does that make sense? Like if C was obtuse, angle C, if I was given something that's obtuse, then it's probably safe to say that that's my biggest angle I can use. Well, it's not safe to say, it is. There's only one obtuse angle, right? In a triangle. So if the actual angle given is 90 or bigger than 90 degrees, you won't be able to bring in that other one because you're using to find the biggest angle first. But if it's acute like that, then technically what's happening is that you're introducing your ambiguous case, and so it's going to be better to stick to law of cosines than law of sines. And it's like a crapshoot. You don't know which one it's going to be. You can't look at it and say, this is one of those that's going to give me a second triangle that doesn't exist. There's no warning. Usually if it's that little, there's a problem, but other than that, there's no warning. Right.
For number 12.
Questions on 49. So we're going to kind of go through how to do it. I don't know if I'll finish it, but I'll at least walk you through how to do it. So it gives you the map. So I said the good news is that because you're not given a map, the information on your quiz is kind of like the reverse. If you can make a drawing from a bearing, that's how you need to understand the bearings as far as your quiz goes. So that it's kind of the reverse information. I'm not giving you the drawing, but you may, depending on your version, you may get one that has bearings on it, and you have to use the bearings to make the drawing. All right, so this one says the information's already labeled, right? The distance between Minneapolis, Albany, and then Phoenix. And it says find the bearings of Minneapolis from Phoenix. So I'm starting at Phoenix, and I need to go to Minneapolis. So I can put my north-south line through Phoenix. I know I have to go north and I have to go east. So I know that's going to be my direction part of my bearings. But now I've got to be able to find this angle on the outside here. There's also a north-south line running through Minneapolis, and there's also one running through Albany. So if you can use those, remember those are parallel lines. All those vertical angles are, all those vertical lines are parallel, which means that all the angles inside it have all those relationships, alternate interior, same side interior, all that good stuff, okay? So again, there's probably like different ways to do this, but the way that my brain saw it was that the angle, that yellow angle, would match this angle on the inside of my triangle. Does everybody see that? Those are alternate interior, and if they are alternate interior and the lines are parallel, what's true about them? They're the same. And then I have that horizontal line from Minneapolis to Albany, which means that this is 90 degrees. So if I could find that top angle, all I have to do is subtract 90 off of it to get the yellow one, and then that would match what's happening on the outside, which would be my bearing. So I want to find the angle, I'm going to call it angle M for Minneapolis. So the cosine of M would equal 216 squared plus 165 squared minus 368 squared over 2 times 216 times 165. So I do the inverse cosine, group my numerator together, 216, 165, 368, 2 times 216 times 165. And I got that big angle at the top, that angle M is 149.7. And then we said that's the whole angle there, so I want to subtract off of it the 90, and I get that little sliver inside here, which is the bearing that would match this one, is 59.7 degrees. And then the second part of this says find the bearing of Albany from Phoenix. So from Phoenix to now Albany is here. I have to go up again, and I have to go over to this point here, which means I'm still going north, I'm still going east, but what changes is I need to this whole angle in here. So if I already found this one to be 59.7, then all I have to do is find what angle, we'll call this angle P because of Phoenix. P is inside the triangle, add that onto the 57 or 59.7, and I get the full bearing there. So if I'm looking for the angle that is formed by Phoenix, then I'm doing the cosine of P equals 216 squared plus 368 squared minus 165 squared over 2 times 216 times 368. So angle P is 13.07. That's what's happening inside the triangle here. So I would add that to the 59.7 to get the entire bearing, which is 72.14.
How do you know that the transversal line, or like the vertical line between, like down the point of Minneapolis and the line from Minneapolis to Albany form a 90 degree?
Just because that Albany and Minneapolis are, that it says due west, and due west means that it's a flat horizontal line.
Okay.
So anything that says due west, due east is going to be a horizontal line. Anything that's due north, due south, that means it's a straight vertical line. Okay. So I published your quiz review. Okay. It's non-graded because I posted the answers right on it. If I could give you one piece of advice is try to do it without formulas. So I actually put the cosine formulas on there, but I would erase them because you're not going to have them. Erase it, try to do it without it. And also, don't look at the answers until you've tried the word problems. Because once you see the answers, you can't unsee them, to some extent. Like I know this because I've seen the diagram. You won't have that diagram yet. So try the word problems. Try them without the diagrams. If you get stuck, obviously that's why the answers are there and to check your work. but you want to definitely be able to do it without having seen the diagrams first. There's a bunch of different types of word problems on there because there's different versions have different word problems, different classes get different versions, different kids within the classes get different versions. So you want to make sure you would know how to do all of them. And I put like multiple of law of cosines and law of sines. If you're comfortable law of cosines and you want to just try a couple, that's fine. You don't have to do every single part. But I would highly recommend going back to law of sines and at least working through the ambiguous case ones so that you know what happens if there's one triangle, if there's two triangles, or if there's none. Okay. And then again, the answers are posted there for you. Tomorrow when you come in, we're 5 minutes shorter tomorrow because you guys are going back to homeroom at the end of the day for PSAT. But we'll still get the beginning of class to kind of go through questions and then do your quiz. I will be in the iLounge today after school and in here in the morning if you have questions. Okay. Parallelograms, yeah. So you got to know the properties of parallelograms. Okay, it's something that's, again, a good thing that you're being forced to review because this is something that's from geometry they haven't seen in a while. Okay, the properties of parallelograms are that opposite sides are the same, opposite angles are the same, consecutive angles are supplementary, and diagonals bisect each other. So for something like 30, so 30 gives you B, this is 25, this would also be 25 if I needed it. C, and I'll be honest, the first time I did this problem, I thought C was just the part segment of the diagonal. It's not. If you read the directions, it says the lengths of the diagonals are given by C and D. Okay, so the whole diagonal is C, which means this whole thing is 50. And diagonals bisect each other in parallelograms, which means that this would be 25 and this would be 25. Obviously, this is not drawn to scale because there's a bunch of different questions based on the same thing, so you can't assume that like that 25 does not look the same size as the other 25. And then D, which is this whole diagonal, is 35, which means that this would be 17.5 and this would be 17.5. So there's probably like 17 different ways to do this, and I happen to just see one of the ways is like the way that I started it. Doesn't mean that if you did it a different way, it's wrong. But for me, if I wanted to find A, I know I either needed to use this big triangle here and know both sides and the angle opposite A, which we have the both sides, but we don't have the angle opposite it. Or I could use this triangle here, need to know the same pieces of information, both sides and the angle opposite it, which again, I don't have, but in my bottom triangle, I have all three side lengths. So I can use all three side lengths there to either find the angle in the bottom right corner, this one over here, or to find this top angle and then subtract it from 180 to get the one on that inside the blue triangle. So there's two different ways to do it. I would say they're both relatively the same as far as like degree of difficulty. I'm going to do the first one. So I'm going to call this angle A because it's opposite from my little a. Okay. And I'm going to find it using this small triangle. So if I do that, the cosine of capital A is equal to 25. Nope, just kidding. 17.5 squared plus 25 squared minus 25 squared over 2 times 17.5 times 25. So second cosine, group my 17.5 squared plus 25 squared minus whatever, so I don't really need both of those, but divided by 2 times 17.5 times 25. And I get that little corner angle here is 69.512, so 5.1. So that's in there. So now I can use that to get side A. I'll just rewrite that one. So now I'm using that triangle, okay? I've got the side lengths, like what looks like almost like it's a hypotenuse, and then the bottom side and the angle opposite the side A, which is 69.51. So I can say that A squared would equal 17.5 plus 17.5, which is my original diagonal 35 degree, or sorry, 35, plus 25 squared minus 2 times 35 times 25 times the cosine of 69.51. So square root of 35 squared plus 25 squared minus 2 times 35 times 25 times the cosine of 69.51. So I get A is 35.177 or 35.8. Cosine of theta would be the two sides to the left and the right of it, which is 35.18 squared plus 25 squared minus 2 times 35.18 times 25. Wait, I'm doing the wrong formula. Just kidding. Hang on. Minus the one across from it, which is 35 squared over 2 times 35.18 times 25. So second cosine, group my numerator together, 35.18 squared plus 25 squared minus 35 squared. 2 times 35.18 times 25. So that's that bottom angle. And then again, properties of parallelograms say that if these two are parallel lines and this is my side connecting them, which would be the transversal, those consecutive angles are supplementary. So to find that last missing angle, I just have to do 180 minus the 68.75. $111.25 degrees. So you do need to know the properties of parallelograms. It's not that in depth on the question. You're like maybe looking for one of those measurements, but you definitely need to know what to do with them.
What if you were to find the like the angle, like the small angle inside a small triangle?
Yep.
What would you do? Like, there?
You'd also have to find the other one in the other triangle. So you'd have to find both of them and add them together.
So it's easier to just
It depends. I mean, it depends on how you see it. Like one time in the last class we found the top angle on that bottom triangle, subtracted it from 180 to get the one inside across from the A, and then use that one to find the A. So there's a lot of different ways to do it.